Dr. Rakesh Kumar Donthi, sir, postdoctoral researcher in University College Dublin. He worked as assistant professor in Jain University. He also worked as associate professor in Gitanjali College of Engineering and Technology, Hyderabad. He is a PhD research scholar on knowledge-based systems. He worked as assistant professor in Gitan University. Now let's all welcome sir to enlighten us on knowledge-based system. So please carry on.
Okay, thank you. Okay, yes. You are able to see my presentation? Hello?
Yes, sir.
Okay.
Yes, sir. We are able to see.
Okay. So today I want to present on knowledge-based system of a particular approach like sentiment analysis on online social media data. It like can be Twitter, Facebook, Instagram, Flickr, like that. Decision making. So what is the architecture and what is the components of knowledge based systems are? First one is knowledge base. That knowledge base containing the facts and rules, and we need to apply the inference engine. Inference engine is nothing but it's a somewhat inference rules, and we are creating the knowledge based system with the inference rules and knowledge rules, and we need to operate all this with a user interface that we know that is human computer interaction. So this is the brief introduction about knowledge based system, and a simple definition about knowledge based system is it is the reason, it is a computer program uses knowledge base to solve complex problems. Then what are these complex problems? Like medical diagnosis, like credit cards checking, and there is a problem of transactions, fraud, like in a very big chemical analysis, and in the whole system of ERP of HR management, human resource management, we are using this knowledge based systems. So what are its limitation? Why what are the limitations of knowledge base? See, sometimes we have not have that expert knowledge in that. The knowledge engineer can't answer it right question about it. It may have knowledge changes rapidly. The knowledge will change in a dynamically. There is a tricks experts who have to do this. So this is the basic knowledge about the knowledge based system. So my approach in this knowledge based system is sentiment analysis. Sentiment analysis comes, it's another, is a part of natural language processing. uh, I have done work on text analysis. I have work done on text analysis like social media data, Twitter. So, so what is this sentiment analysis? Is nothing but people's opinion towards entity of computational study. It refers to the natural language processing, and it's a computational linguistics to identify subjective information and source material. So next. So this sentiment analysis can be a different types. First one is about polarity. It is nothing but fine-grained sentiment analysis. Second one is emotion detection. It is nothing but lexicons, like polarity lexicons like WordNet, all those things like polarity can be a positive, negative, neutral. Then another one is aspect-based sentiment analysis, like review on TV, volume on that, based on one aspects like e-commerce. Then there is an intent analysis, seeing message when we express intent, like by seeing the somewhat message we explain like WhatsApp, like that. Next. So see, this sentiment analysis, also called as, other names are opinion extraction, opinion mining, sentiment mining, subjective analysis, review mining, appraisal extraction. So these are the methods of sentiment analysis. First one is rule-based approach. We'll do sometimes manually or with the help of sentiment scores. And we have another automatic sentiment analysis now, the present demand area, that is machine learning and deep learning. So my scope of work in this are, first of all, I did a data extraction with the use of APIs like REST API, streaming API, by using beautiful soap library, web scraping, and that is so uh, the main concentration on social media data. We are using APIs to download the data. That is the process of web scraping with the Python library called a beautiful scope. And for sentiment analysis, we use another library called as TextBlock. So after that, getting the data, we have to do the pre-processing. That pre-processing can be done with NLP techniques like stop word removal, lemmatization, tokenization, parts of speech tagging, stemming, all those things. Then after getting the data, we can apply feature extraction, or we can do the other approaches like methods of classifications, like using algorithms of machine learning and deep learning. So next. So I have not only done on this work, I have done some other work like ontology. I have worked on ontology. So there is a problem of storing the data in normal relational database. So it has difficulty to answer the complex queries, and it has, and this relational database like SQL will answer only at most one result only. Some properties such as transitivity, symmetric are lagging in that. There is a boundary like the closed word assumption in the relational database. So I went to other approach like ontology, and we are using query. That there the query is Sparkle query. There we use the intelligence that is also related to knowledge based system. So this is my total work contribution. Like tweets, we are taking social media data, we are doing web scraping. The not only I did pre-processing on the NLP techniques, after that I have done the different like multi-level filtering and topic based filtering. Then that data I have applied for future selection and did opinion classification. Finally, after getting the classification results, converting, then I apply the ontology on that. And I upload the ontology that
Sir, your screen is not visible, sir.
not visible.
Yeah, it's blank.
Okay, okay. Because of image it was like that. Now it is okay.
No, sir, not you.
Data is visible now. Hello,
No, sir,
hello.
like, no, it's still blank, sir.
Blank. Okay, okay. I will apply again.
Your cam is visible, sir, but not your screen.
Is it okay now? Hello, hello.
Yeah, sir, it's visible now.
Okay,
Yes, sir, we are able to hear you.
okay. So now have talked about this architecture. Again, I am telling this is the main architecture about framework about that. This is the like workflow of anyone working on artificial intelligence or on machine learning and deep learning. This is the same workflow. Added to that, I have a knowledge based system of one approach is ontology. So social media data now we are getting with the APIs. Then we are doing processing, and we are applying different NLP techniques, and we are having different tools like NLTK, like all those things. Then we do the extraction, feature selection, and apply classification. And this is the approach for contribution. So in my work, one module is about web scraping, I told you. Then pre-processing like NLP techniques, like multi-level filtering and topic-based filtering. So this multi-level filtering is nothing but I have concentrated on railway tweets, Indian railway tweets. Not only we have to concentrate on the tweets which are inclusive filter, which are domain of Indian railway, then which are having relevant to my approach, like my work on the Indian railway tweets on based on their decision of uh, punctuality, staff behavior, security, cleanliness, food quality of the train. If the train is going for one place to other place from Hyderabad to Vijayawada, so what is the facilities of punctuality, staff behavior, security, cleanness, food quality? So that is my relevant, and I want only the opinion filters, like opinion tweets only, not other tweets like about budget or platforms and all those things. So this is one technique of this multi-level filtering. And there is another work also I did on that, that is topic based filtering. This is the diagram about topic based filtering. This is the diagram of topic based filtering. Once, okay, topic based filtering I have done not only on the multi-level. I identify the topic. That's what topic I have identified: punctuality, staff behavior, security, food quality, cleanliness. Then on that, I apply the lexicon building. That lexicon building is nothing but we have given the labels of the tweets, whether it is positive, negative, and neutral. And after that, I apply the concept extraction. The concept extraction is that uh, once we are having the as it is having the semantic aware analysis or not, between the text there is a semantic aware analysis or not, I have identified. After that, I have uh, detected the subjectivity. Is it factual tweets, or it's reflecting a more opinion or not? That is nothing but subjectivity detection. And finally, I have done the polarity detection again with the centiword. And finally, I find the disclassification of the finding error rate between the tweets. So this is the one framework I have worked. This is the novel approach on this the filtering processing of different way I did. I present a paper in this, and I got a best paper award in NIT Trichy on this. So this is the framework. Again, I want to tell the multi-level data where it is having inclusion filter, relevance filter, opinion filter, and given to the topic selection. Topics I told you: punctuality, staff behavior, security, cleanliness, food quality. Then given the lexicon of like polarity detection. Lexicon can be a word net or centiword net of it. And subjectivity is nothing but the semantic awareness. Concept is nothing but a semantic awareness. And then we have a subjectivity. Is it having the factual or real opinion? Then I apply a polarity detection with the ordinal classification. Let's misclassification of 22 to that is nothing but error rate. So next, after this, uh, I have converted the tweets based on the some parameters like train domain, train number, like tweet ID, future number, opinion value, and tagging in the tweet. Who are tagging in the tweet, who are having the opinion value, who are having the future, you are having the twitch train number and the train domain. So this is the output I got it. Like if it is the train domain, it is 111. It is not in a domain 0. These are the train numbers like 12403, 12164, 1037, 12444. All these are the train numbers. This is the idea of it, the tweet idea of it. And based on this are this 5 2 3 2 1 are nothing but the mm, train the attributes of that. Like if it is 1 is punctuality, 2 is um, staff behavior, 3 is cleanliness, 4 is food quality, 5 is security, like that. 0 means it is having the opinion as neutral. 1 means it is having the opinion as positive. -1 is it is having the opinion as negative. So these all are the things who are tagging, like 53, 58, 58 is always tagging, like 3 to 75, 3 to 75 is tagging, like these are the tagging persons. This is the third part of my work. First part is social media data. Second part is web scraping, all those things like beautiful soap text box. Third part is feature extraction. So third part is pre-processing that I did in a 3 ways, like normal level and multi-level and the topic level. Then future extraction. Then I went for the classification. In this classification, I use the assemble classification, not only based on the single approach of machine learning. I combine the machine learning and deep learning algorithms with approach of like stacking. Someone may go for boosting, voting, or stacking. I went in the approach of stacking because it may be I gone through some literature survey and some benchmark papers to know that it is better to go on stacking. So these are, I have used the algorithms like Navy Base and support vector machine and LSTM, so of RNN, and I got the results like this. So this is the classification approach I have used it. And then I have the last module of my work is on ontology. So why we are developing a knowledge-based system using ontology of semantic analysis data of Indian Railway. This is the basic diagram of it. So databases will get, we are having the RDB schema. This is resource description based schema, and we are applying for resource description framework. Then to the ontology, I have created the ontology. Actually, there will be number of ontologies ready-made we get, but I have applied the tool and I got the results. So we can, after the ontology, the part is we'll apply the tool, we'll give the knowledge rules for it, and we'll query it. So, so basically, I want to tell you what is ontology, the definition of ontology, and why, what is the use of ontology. So, okay. So ontology is a knowledge representation. What is ontology? Ontology is a knowledge representation. So, so this ontology contain the RDF schema. So what is RDF schema means? It provides the data modeling. What RDF schema does? It does the data modeling. So object oriented, like data modeling, like object oriented, entity relationship, all those things. So this RDF schema provides the data modeling for RDF. What is RDF? RDF is a resource description framework. Actually, before going to the ontology, you have to know what is this area. The area of this ontology is semantic web. This is the one of the important part of artificial intelligence, one of the branch of artificial intelligence. This semantic web is nothing but you are searching in a Google, that you are searching based on the keywords. Like you are searching Apple, it may get the Apple fruit or Apple iPod. So, but this semantic web gives you more semantic aware analysis, like semantic data based on subject object predicate of your words. The text you are typing, in that it will give in a triplet form. Triplet form is nothing but subject, object, and predicate of what you are searching. This is the way the RDF framework has designed. This is the way OWL, ontological language, is designed. So it contains like just like what you have approached in a UML, your object oriented, you have a software UML. This is also containing the objects, attributes, range. Somewhat the other extension of it is like it containing the domain, ranges, data properties, and object properties. Some of the slides I will show the how I operated these two. So now we'll come into the somewhat implementation of ontology. So this is the one of the part of ontology. We can create the classes, subclasses, objects in this, and this is the, it will create a graph also. This tool, this is the protege tool. It is a nothing but ontograph. We are creating the ontograph. This is the way we can see while you are operating this, we will get the ontograph. Then this is the way, this is nothing but we are creating the data properties, like what are the data properties we are having, what are the object properties we are having, we are showing. Developing of knowledge based system using ontology of semantic analysis, like data set of Indian Railway. So this is very important. These are called as rules: production rules, knowledge rules, or inference rules. This is the important part of our knowledge based system. The ontology we are creating, it is run with the intelligence. The intelligence runs with the production rules or inference rules or knowledge rules. It can be a, we can write like this, or we can write with first order logic, or what I have written in my paper I will show you. Means my work, this is the way I have written. Like suppose there is a, like train, cleanliness, star behavior, sentiment. I have combined this. I like security, food quality, star behavior, and the sentiment. These are the rules I have created. S1 and S2. These are these are present in the SWRL tab. SWRL is nothing but semantic web rule language. What is SWRL? It's a semantic web rule language. It is in ontology. Recently, I published a paper in this ontology with my students of 𝐬𝐥𝐻𝐿𝐼 College of Engineering, where I have also worked as an associate professor for 2 years. This paper, one of the ontological functionality of this protege tool implementation, they have published. So this is nothing but execution of SPARQL query. It's like same similar to structure query language. Like here I have written the like we have to import the prefixes from the RDF, OWL, and SWRL, and schema and DTD. So here is the query I did, like select subject object question mark. Like this is the way we will write, where subject RDF subclass of object. So we are getting the output like these are the things like output we got, like subjects and objects we are getting. This is the small implementation. If you go into the in depth of implementing the protege tool, we will get the results according to our application. So conclusion I want to do. So yes, hello, hello. So the proposed framework is having the knowledge-based sentiment analysis, extracted data set from the Twitter using beautiful library. Further, we process the data using NLP techniques, multi-level filtering, topic-based filtering to get the efficient data set. Afterwards, we created the future vector of data set in input the machine learning classification. And for classification of different data set, we are using a single classifier approach, and such as Navy base like SPM and LSTM. We can have this future work like we can do a well-informed decision, and knowledge-based sentiment analysis need to be improved with good improved with algorithms, all those things, and approach framework will be in a different way. So this is the part of my previous work. Now I want to show you the present some work which I have done in my here in a postdoc. So I want to show you the other work what I have done recently. I came here 3 months back, so I have a present work somewhat what I have did. So this is the thing. So I'm working here on the green spaces. So I'm working on the green spaces. So there is a there is I have decided to work on the social media data, and here also using the NLP techniques, like we have to create the dashboard. So there are the languages like Python I'm using, and front end technologies like Streamlit, Python visualization packages. Then backend technologies like Python packages of for sentiment analysis and social media are like and concentration on spatio-temporal analysis of geo visualization packages. Like we can see the uh, online map of the particular location and find the coordinates, find the centroid of it and geolocation, and apply the sparkle or sorry spatial query on that. The databases I'm using presently, I'm using spreadsheets. I'm getting like 1,000 to 2,000 tweet on particular in a particular year, particular park. So like that. So this is the somewhat design I did on that, the Python and the spatio-temporal analysis, sentiment analysis, like social media data like Twitter, Flickr, Instagram, based on the geo information and visualization using web application. So this is the architecture, and I work like user input giving to the dashboard. We are getting the request and response on the Streamlit app, and it can having the visualization. The libraries used for the visualization are Plotly, Matplotlib, Pandas, and databases axis we are using our spreadsheet, MySQL, and MongoDB. The sentiment analysis we are using, and the sentiment analysis containing the different packages like Twippy. I'm using Streamlit. The transformer is the package which helpful for running the hugging face of deep learning algorithm, and spatiotemporal some of the libraries like Floium, GeoPandas, and GeoPlot. So this is the one video I want to show you. You can see that one video I have created on my how I'm working on this. I have created a one video. You can see see this video. Here is the we can give like we can give the about what visualization you want and what sentiment of the tweets you want. It will be downloaded. Number of tweets by sentiment with the visualization. Like what type of charts you want, you will get it. Here is I have taken the default of US Airlines sentiment and analysis of tweets about US Airlines. We can get the geolocation of that who are tweeting like that. We are getting the location of also there. Okay, I want to again run the video one more time so that it will be. So this is the one of the scenario with live data. Like we can have a application with app or website like sentiment topics and heat maps. We are concentrating on visualization technique like heat maps, tag cloud, timeline, map, affinity, and narratives and tweets, all those things. So we are running in the local host in a server with a particular network.
Sir, you have been muted, sir.
Hello.
Yeah, sir.
Yes, completed. Hello. Hello.
Yeah, sir. Yeah, sir. Yeah, sir. We can hear you.
Any queries?
None, sir.
Huh? Hello.
No, sir. No queries.
Okay. Can I log out?
Sure, sir.
Hello.
Yeah, sir. We'll just give the outro. 1 2 minutes. 1 moment. Ashwini, please
Okay.
give the
Okay.
outro.
I'm sorry, sir. My network was bad.
Okay. 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 No problem. My lecture is clear to you, everyone. Like presentation or voice or everything. Presentation, everything.
Yes, sir. Yes,
Yes,
sir.
sir. That's very good.
Okay. 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 Thank you.
So every day holds the possibility of a miracle. So keep hoping for the best and keep shining. On behalf of the entire NGC Club and VIT, I would like to thank our honorable speaker. Thank you for inspiring and encouraging us with your words. And special thanks to our coordinator, Ganesh Reddy sir, for supporting us on every event and webinar. And last but not the least, I would like to extend my gratitude to our audience for coming and making this webinar a success so much. Thank you, sir.
Okay, thank you.